Okay, today we're learning about solving systems of linear equations by the elimination method or addition. In your book, I think it's called the addition method. Everywhere else, it's called the elimination method. I know I've got this when I can use the elimination method to solve a system of equations. So what is the elimination or addition method? It is a second algebraic technique for solving a system of equations. We rely on a version of the addition property of equality, which state that equal added to equals are equal. It's actually my favorite technique of doing this. I really like it. Go ahead and pause and read over this and write notes down, please. So number 1A. All right, solve the system. So we are going to eliminate a variable by adding the two systems together, by adding the two equations together. So if I add these two together, x plus negative x, that will be eliminated. Negative 3y plus 1y is negative 2y. Negative 3 plus a negative 1 is a negative 4. Then I just solve for y, so divide both sides by a negative 2, and y equals 2. Once I find one variable, I substitute it in either one of the equations and find the other variable. So I'm going to substitute in the second one because that one looks like the easiest. So negative x plus y, or 2, equals negative 1. So I need to solve for x, so I'm going to subtract 2 from both sides, and I would get negative x equals negative 3. Divide by negative 1, so I get x equals 3. So the solution to that problem is 3, 2. So let's go over it one more time because I went through that pretty quickly. So if you want to solve by elimination, you add the two equations together. When you do, you will get x plus a negative x is eliminated. Negative 3y plus y is negative 2y. Negative 3 plus a negative 1 is negative 4, and then you go from there. All right, let's do this one. So now if I add those two equations together, nothing is going to be eliminated because I don't have any additive inverses. So I need additive inverses to make this happen. I'm going to rewrite the system over here. So 3y minus y, 3x minus y equals 4, and 6x minus 2y equals 4. Okay, so here's what you do. If you don't have any additive inverses, you need to get them. So choose which variable you want to eliminate. It does not matter. I'm going to say I want to eliminate the x. You can eliminate the y. It really doesn't matter. All right, so if I want to eliminate the x, I'm look at the 3 and the 6. What is the least common multiple of 3 and 6? 6. So since I already have a positive 6, I need to change this to a negative 6. I can do that by multiplying the whole equation by a negative 2. When I do that, I'm going to get negative 6x plus 2y equals negative 8. So now I'm going to add the two equations together. And when I do that, everything is going to be eliminated. So I get 6x plus a negative 6x, that cancels out. Negative 2y plus 2y, that cancels out. Equals 4 plus a negative 8, which is negative 4. And that is not true, so I have no solution, which means that these are parallel lines and they're inconsistent. All right, let's try another one. Okay, so again, these are, I don't have any additive inverses. Okay, so I'm going to write it again. Negative 2x plus y equals negative 5, and 8x minus 4y equals 20. Okay, so we want to, let's say, get rid of the y this time. Okay, so look at your coefficients in front of the y's. You have 1 assumed to be there and a negative 4. So what is the least common multiple of 1 and 4? 4. So since I already have a negative 4 here, I need to multiply this by a positive 4. Okay, so when I do that, I'm just distributing this. I would get negative 8x plus 4y equals negative 20. So when I add these two equations together, I would get 0 equals 0, which is true. So you have infinite solutions. meaning these two lines are on top of each other. They are dependent lines. They're coinciding, so they had infinite number of solutions. All right, so here are some for you to do, but I don't feel like we're quite there yet. So let's try to do some of, we'll do, I tell you, we'll do E together. How about that? Let's do E together real quick. Okay, so we have negative 2x plus y equals 2. And negative x plus 3y equals negative 4. So let's choose one. I'm going to say let's eliminate the x. So that means that I need to look at the coefficients in front of the x. So I have negative 2 and negative 1. What's the least common multiple? 2. So since I already have a negative 2, I need to make this a positive 2. And I can do that by multiplying the whole equation by 2. Now I'm going to just rewrite the first equation. So I'm not doing anything, I'm just rewriting the first equation. And then in the second thing, I'm going to distribute that. So I would get 2x minus 6y equals 8. So when I do this, I'm going to get the x's would be eliminated, right? 1 minus 6 is negative 5y. 2 plus 8 is 10. I'm going to divide both sides by negative 5, and I would get y equals negative 2. Now, I want to substitute y equals negative 2 in either one of the equations to find out what x would equal. So I'm going to plug it into the top one. Okay, so I've got negative, and it doesn't matter which one you do. Negative 2x, I'm plugging in right here, plus y, which means minus 2, equals 2. All right, so I'm going to add 2 to both sides, and I would get 4. Divide by a negative 2, and you get x equals negative 2. So that means the solution to E is negative 2, negative 2. All right, so pause the video and you try the rest. Okay, and these should have been your answers. All right, here's some more. So solve the system, and we have 6x minus 3y equals negative 3, and 4x plus 5y equals negative 9. Now, what's the problem? You want to eliminate, but you don't have any of the same numbers, okay? So I'm going to eliminate the x. How do I do that? Well, what is the coefficient? What's the least common multiple of 6 and 4? 12. So I need this one to be a positive 12, so I need to multiply by 2. And I need the second one to be a negative 12, so I'm going to multiply by a negative 3. Now distribute into both of those. So you get 12x minus 6y equals negative 6, and negative 12x minus 15y equals 27. So when I add those together, the 12x's would eliminate. Negative 6 minus 15 is negative 21y. Negative 6 plus 27 is 21. I solve, I isolate the y, so I'm going to just divide both sides by negative 21, and I would get y equals negative 1. Now, once I have that, I'm going to plug it into either one of the equations. I'm going to plug it in here just because I feel like it. So I get 4x plus 5, y, which is negative 1, equals negative 9. So I'm going to get 4x minus 5 equals negative 9. Just isolate that x, so add 5 to both sides. 4x equals negative 4. Divide both sides by 4, and you get x equals negative 1, which means the solution to this equation is negative 1, negative 1. Okay, 2B. Solve the following system using elimination. Now, I know what you're already thinking. Oh my gosh, this has got so many fractions. Well, it's get rid of them. If you don't like them, get rid of them. How? Multiply by the least common multiple. Okay, so what's the least common multiple in the first equation? 12. So if I multiply by 12, I would get 24 over 3 is 8. 12 over 4, 3. Negative 36 over 2 is negative 18. That's the first one. The second one, what am I going to multiply by to get rid of the equation, get rid of the fractions? 4. So 1/2 of 4 is 2. 1/4 of 4 is 1. Negative 2 times 4 is negative 8. Now we have something that's a lot easier to deal with. Okay, so we still have to eliminate though. So I think it would be easy to multiply the second equation by 3 so I could eliminate this y. So I'm going to just rewrite the first equation again. So I've got 8x plus 3y equals negative 18. And now I'm going to distribute that 3 into the second equation. So I get 6x minus 3y equals negative 24. When I add those together, I'm going to get 14x equals negative 42. And if I divide both sides by 14, I get x equals negative 3. Now put that back somewhere that it's easy to figure out. So I think maybe the first equation, let's do it in the second equation. So 2x, negative 3, minus y equals negative 8. So that would be negative 6 minus y equals negative 8. Add 6 to both sides. You get negative y equals negative 2. Divide by a negative 1, and you get y equals 2. So the solution, which means, remember, these are where those two lines would intersect, is at negative 3, 2. So you have a consistent, independent solution set. All right, here are 2 problems for you to do. Remember to get rid of those fractions on letter D. Pause it and work them out. And you should have gotten that as your answer. Okay, here's some extra practice I want you to try to solve. Let me give you a tip real quick before you get started. On J, do you see it? It's got all these decimals that look horrible. Well, just how you can multiply by the least common denominator with fractions, you can multiply by powers of 10 to get rid of the decimals in J. So instead of all the decimals, you would be dealing with 35x plus 3y equals negative 187. And then 7x plus 9y equals negative 71. So it's still not great, but it's better. So go ahead and pause it and work those out. And your answers are right there. So let me know if you need help with these. So I know I've got it when I can use the addition or elimination method to solve a system of linear equations, but do you really understand? So suppose 2 equations in a system are added together and the resulting equation is 0 equals 0. What does that mean about the graphs of these equations? And how many solutions does the system have? It means the graphs of the equations are identical and there are infinitely many solutions to the system.